All right, number 25 is another one that if you're looking back through the book, you want to go to that section on differentiability and continuity. So maybe section 4.6, somewhere there in the book, around chapter 4. And so remember that a couple things need to happen. For a function to be differentiable, you can't have a cusp, okay? Which means that if you're going to have a smooth curve, if you're looking at any particular point, you need to be approaching the same slope from the left and from the right, okay? Because at a cusp or a corner, you're approaching different slopes from the left and the right. So you've got to have the same limit of the slopes from both sides. In other words, the limits of the derivatives need to be the same. The other thing is, your function's got to be continuous, okay? I can't talk about having a slope if there's a break in the function, okay? So it really has to be two things. It has to be continuous and it has to be differentiable, okay? And sometimes one of these things is easier to show than the other. So remember, for a function to be continuous, it has to approach the same value from both sides as we approach a value of 2. And so we're talking about the idea of a limit as we come into 2. So we can look at the left-hand limit, the limit as we approach 2 coming from the left. That was for values of x that were less than 2. That's this equation right here. So cx plus d has to have the same limit coming from the left as the limit coming from the right. And this is a good example of a question that could be a multiple choice question or on a free response. And for a free response, make sure you've got those limits there, okay? They don't give you points for continuity or differentiability problems unless you show limits, okay? They don't see limits, they just quit grading, okay? So again, let them know, yeah, I took calculus, I know this stuff. Anyway, so the two functions have to approach the same thing from both sides. And again, there's nothing funny going on with these limits. I can just substitute 2 in here, so I get 2c plus d. 2 squared here is going to end up being 4. Actually, you know what? I'm being lazy here. This limit here, if I evaluate it, I'm really subbing in. It would be 2c plus d. The limit over here, I would be substituting in 2 there. That would be 4. And if I sub in 2 for x there, that would be plus 2c, okay? So right now we've got 2 variables there, nothing we can do with that. Let's talk about differentiable. So if this is going to be differentiable, it's got to be a smooth curve. The slopes on the left have to be equal to the slopes on the right. We already said differentiable. We're talking about the derivatives approaching the same values from the left and right. So let's set the derivatives equal from the left and right. Actually, let me go ahead and write down this equation here. We need 2c plus d to be equal to 4 plus 2c. Hopefully that stays on camera. And so now we need the limits of the derivatives to be equal, okay? And so we'll take the limit of the derivative coming from the left. This is the one where x is less than 2. That's a constant, so power rule here. 1 times c, drop the power by 1. We just get c. Derivative of a constant is 0, so that's gone. That's a really easy one. And then we need to look at the limit of the slope over on the other side. That derivative there is 2x minus c. That's a constant, right? 1 times c, drop the power by 1. Okay, the limit of this as x approaches 2, we can sub in 2 there. We'll get 4 minus c has to be equal to c on the other side here. Add 2 to both sides, or add c to both sides, we get 2c equals 4. So c has to equal 2. Okay, now I can put 2 back up here for c, and I probably can find everything now, right? I have 4 plus d is equal to 4 plus 4, and that looks like d has to equal 4. And they want c plus d, right? So c was 2, and d was 4. Do we have a choice there of 6? Oh, we do not have a choice of 6. So what did I do wrong here? Let's see. So 2c plus d is equal to 4. Oh, there it is. Sorry, that's supposed to be minus 2c. Okay, so that's minus 4. So d should be equal to negative 4 there. Okay, negative 4 plus 2 should give us an answer of negative 2. Is that an answer? Yes! 25 looks like the answer is B, negative 2.